Are you tired of finding limits the long way? Are you sick of doing long division just to find the limit of a function as it approaches infinity? Well, suffer no longer with L'Hopital's rule. Hi, Captain Calculus here, and I'm going to show you how to find limits in a snap. Okay, let's say you have this equation. The limit as x approaches infinity of x squared minus x minus 10 over 5x squared plus 12x minus 2. Now, at first glance, this might look complicated, but it's actually quite simple. All you have to do is plug in infinity for x. And if you get infinity over infinity, then what you have to do is take the derivative of the top and the bottom and set the top over the bottom again. So 2x minus 1 over 10x plus 12. Now, we do the same thing we did the first time. Plug in infinity for x, and again we get infinity over infinity. So all we're going to do is take the derivative of the top and the bottom again. Limit as x approaches infinity of 2 over 10, which reduces to 1 over 5. And there you have the answer. It's that easy. But wait, there's more. If you want your limit finding experience to be even speedier, let me introduce you to my friend BoboBots on SportsCenter, and they will explain.
Thanks, Captain Calculus. If you want to find the limit of a function as it approaches infinity in a jiffy, use the patented BoboBots on SportsCenter method. Look at the highest degree of x in the numerator and in the denominator. If the degree is bigger on bottom, the limit is 0. If the degree is bigger on top, the limit is a slanted asymptote. If the degrees are the same, look at the coefficients of those highest degrees of x. Let's take a look at that same function. The limit as x approaches infinity of x squared minus x minus 10 over 5x squared plus 12x minus 2. The highest degree of x in the numerator is 2. The highest degree in the denominator is 2. They're the same, so we're going to look at the coefficients. The coefficient of x squared is 1. The coefficient of 5x squared is 5. So the answer is 1 over 5. As you can see, we got the same answer that we got using L'Hopital's rule. It's that easy.
And if you don't believe us, listen to our satisfied customers.
I have to find this limit for my homework. The limit as x approaches infinity of 3x squared minus 2x plus 7 over x squared minus 10x plus 5. I can use L'Hopital's rule. So I plug in infinity for x, and I get infinity over infinity. So I need to take the derivative of the top and put it over the derivative of the bottom. The limit as x approaches infinity of 6x minus 2 over 2x minus 10. When I plug in infinity again, I still get infinity over infinity. So I need to take the derivative of the top over the derivative of the bottom. The limit as x approaches infinity of 6 over 2. And that's my answer. 6 over 2 simplifies to 3. The limit as x approaches infinity of 3x squared minus 2x plus 7 over x squared minus 10x plus 5 is 3. Thanks, Captain Calculus.
This is my homework problem. The limit as x approaches infinity of 7x plus 20 over x to the 5th minus 2x to the 4th plus 5x plus 3. Now, there's a special little thing we get to use here that we talked about earlier called BoboBots at SportsCenter, which is very nice for this one especially because as we see here, the highest power in the numerator is 1, but the highest power in the denominator is 5. And since it's bigger on bottom, BoboBots, that part of BoboBots, the B-O-B-O, we know that the answer is 0. Thanks, BoboBots on SportsCenter.
Now I can do this homework problem. The limit as x approaches infinity of 5x cubed plus 70x squared minus 12x plus 15 over 2x cubed minus x squared plus 28x minus 82. Doing this with long division was way too hard, so I'm going to use L'Hopital's rule. I need to take the derivative of the top and put it over the derivative of the bottom. The limit as x approaches infinity of 15x squared plus 140x minus 12 over 6x squared minus 2x plus 28. If I plug in infinity for x, I still get infinity over infinity. So I need to take the derivative of the top and put it over the derivative of the bottom. The limit as x approaches infinity of 30x plus 140 over 12x minus 2. We still have some x's in there, so if I plug in infinity for x, I will still get infinity over infinity. I'm going to take the derivative one more time to get rid of those x's. The limit as x approaches infinity of 30 over 12. 30 over 12 simplifies to 5 over 2. And that's my answer. I know it's right because if I did the BoboBots on SportsCenter method, I would look at the coefficients of these x values because they're both cubed. And the coefficients are 5 and 2. So the answer is 5 over 2. Thanks, Captain Calculus.
Another student saved by L'Hopital's rule and the BoboBots on SportsCenter method. And they can save you too.
If you want to find limits approaching infinity, it'll only cost you a semester of your life and your sanity. Be sure to ask preguntas if you don't understand. Memorize your formulas. Do your note cards. Warning, drawing a smiley face on your test and turning it in will result in a failing grade. Remember your 6 Ps. The only purchase necessary is a 5-subject notebook.